January 17th, 1942, Detroit, Michigan. The night air hung thick with the smell of burning coal and molten iron. Snow fell softly over the Rouge River plant, each flake dissolving the moment it touched the glowing rivers of steel that poured through the casting channels inside the cavernous halls of what had once been the world's largest automobile factory. The night shift changed over with the precision of a military drill. Men in heavy canvas jackets and leather gloves moved between machines that had, only months before, been stamping out civilian automobiles. Now they shaped armor plate. The sound was different, heavier, more insistent. Where once the rhythm had been the light percussion of fenders and hoods, now it was the deep thunder of tank hulls taking form. In a corner office overlooking the factory floor, a procurement officer named Raymond Dietrich stood with his hands pressed against the cold window glass, watching the sparks rise like fireflies into the darkness. He held in his other hand a telegram from Washington. It contained a number that seemed impossible. 2,000 medium tanks to be delivered within 18 months. The entire American armored force at that moment consisted of fewer than 400 tanks, most of them obsolete. The steel required for such an undertaking would exceed the entire annual output of some European nations. And yet the order was absolute. What Dietrich could not have known, standing there in the winter darkness, was that this impossible demand would trigger a metallurgical revolution, one that would turn America's junkyards into arsenals, its scrap heaps into strategic reserves, and its culture of waste into an unexpected weapon of war. Nor could he have imagined that 3 years later, in the ruins of the Ruhr Valley, German engineers would stand in their own factories, staring at the same impossible mathematics from the opposite side. Their furnaces cold, their alloy stocks exhausted, while American tanks rolled past their windows in endless columns, each one a testament to an industrial philosophy they had dismissed as primitive, wasteful, and beneath the standards of German engineering excellence. The story of how America built 2,000 tanks from scrap metal while Germany starved for steel is not simply a tale of production numbers. It is the story of two civilizations that approach the problem of war from fundamentally different philosophical directions, one that believed in precision, purity, and control, and another that believed in volume, adaptability, and the redemptive power of second chances. It is a story about what happens when the careful plans of brilliant minds encounter the chaotic abundance of a society that had never learned to throw anything away. When Adolf Hitler came to power in 1933, he inherited an industrial base that was, in many ways, the envy of the world. German metallurgy was a science that other nations studied with reverence. The Krupp works in Essen produced steel of such quality that its composition was a closely guarded secret. German engineers had perfected the art of alloying, the precise mixture of chromium, nickel, molybdenum, and manganese that gave their armor plate its legendary hardness. Every batch was tested, measured, and certified. The steel that went into a Tiger tank had been refined through processes that eliminated impurities down to the parts per million. It was steel as philosophy, pure, strong, incorruptible. This precision came at a cost, though it was not a cost the Germans recognized as such in the early years of the war. Their furnaces required virgin ore, preferably from Sweden, where the iron mines produced material of exceptional purity. The alloying elements had to be imported: nickel from Finland, chromium from Turkey, molybdenum from Norway. Each tank that rolled off the production line in 1941 was a masterpiece of controlled metallurgy, its armor plate hardened to resist penetration, its mechanical components machined to tolerances measured in hundredths of a millimeter. German tank crews spoke with pride about their vehicles. They were not merely machines. They were instruments of precision warfare, extensions of a military tradition that valued quality over quantity, craftsmanship over mass production. In the summer of 1941, as Operation Barbarossa drove deep into Soviet territory, this philosophy seemed vindicated. German tanks outclassed their Soviet counterparts in nearly every engagement. The Panzer III and Panzer IV were not the largest or the fastest tanks on the battlefield, but they were reliable, well-armored, and crewed by men who had trained for years in their operation. When they broke down, They rarely did. The parts to repair them were standardized, interchangeable, manufactured to exact specifications. The German way of war was a clockwork mechanism, each component fitted perfectly to the next. But wars are not won by individual tanks no matter how well made. They are won by the thousands of tanks, by the weight of metal that can be sustained over years, across continents, in the face of losses that mount with arithmetic cruelty. And here, in the mathematics of attrition, the German system began to reveal its fragility. By the winter of 1942, the Wehrmacht had lost more than 2,000 armored vehicles on the Eastern Front. Replacing them required steel, millions of tons of it, and the steel required ore, and the ore required ships to transport it, and the ships required fuel, and every link in this chain was under assault. British bombers targeted the Ruhr Valley. Partisan raids disrupted the rail lines from Sweden. The mines in occupied territories were sabotaged, their output reduced to a fraction of peacetime levels. And even when the ore arrived, the German furnaces faced a problem that their engineers had never seriously considered. The steel they needed could not be made from scrap metal. The twisted wreckage of destroyed vehicles, the offcuts from manufacturing, the demolished remnants of bombed factories, was, in German metallurgical practice, largely unusable for high-grade armor production. The problem was contamination. Once steel had been alloyed and hardened, breaking it down and remelting it introduced impurities that were nearly impossible to remove: phosphorus and sulfur, which weakened the crystalline structure of the metal, accumulated with each recycling. Trace elements from previous alloys created unpredictable interactions. The result was steel that looked acceptable on the surface but shattered under the stress of combat. German quality control standards, which had served them so well in peacetime, now became a limitation. Scrap could be used for lower-grade applications: railway tracks, construction beams, non-critical components. But not for the armor that stopped shells or the engine blocks that endured the shock of rough terrain. Albert Speer, the Reich's Minister of Armaments, understood this problem with growing alarm. In a memo dated March 1943, he wrote to Hitler explaining that German tank production was constrained not by factory capacity or labor availability, but by the availability of virgin alloying materials. The word he used, bottleneck, was bureaucratic, almost mundane, but it represented a crisis. Without chromium and nickel, Germany could not produce the steel for new tanks. And the sources of chromium and nickel were, by 1943, largely beyond German control. Turkey had ceased exports under Allied pressure. Finland's mines were small and already operating at capacity. Captured Soviet stocks had been depleted. The German solution was to reduce the quality of their steel, not dramatically but incrementally, in ways that would not be immediately apparent. Armor plate specifications were quietly revised. The nickel content was reduced by 5%, then 10%. Chromium ratios were adjusted, heat treatment times were shortened. Each change was justified by engineers who assured Speer that the degradation was minimal, that the tanks would still perform adequately, and in testing, under controlled conditions, they did. But testing was not war. War was a tank taking a hit from a Soviet 85mm gun at close range. The shell striking not the thickest part of the glacis, but the weld seam where two plates met. War was metal that had been rushed through the hardening process, its crystalline structure not quite uniform, developing a hairline fracture that spread under stress until the entire plate spalled, sending fragments into the crew compartment. War was the moment when precision became a luxury and volume became survival. And Germany had built its entire industrial philosophy on the assumption that precision would always matter more. 3,000 miles to the west, America faced the same problem from the opposite direction. In January 1942, the United States had steel in abundance. The problem was that most of it was in the wrong form. It sat in junkyards and vacant lots, in the rusting hulks of Depression-era automobiles, in the demolished frames of torn-down buildings, in the obsolete machinery of closed factories. It was scrap, millions of tons of it, and it was everywhere. Before the war, this scrap had been an embarrassment, a symbol of waste and economic failure. Now suddenly it was a strategic asset, if only someone could figure out how to use it. American metallurgists approached scrap metal with a pragmatism that would have horrified their German counterparts. They did not aim for perfection, they aimed for adequacy at scale. The philosophy was simple. If scrap steel could not meet the standards for armor plate, then change the standards. If impurities could not be completely removed, then dilute them to acceptable levels. If the crystalline structure was inconsistent, then design around the inconsistency. The question was not whether the steel was pure, but whether it would stop a shell. And if it would stop a shell, even imperfectly, even with a higher chance of cracking, then it was good enough, because the alternative was no tank at all. The technical breakthrough came not from a single invention, but from a shift in industrial practice. American foundries began blending scrap with virgin ore in carefully calculated ratios. A typical melt might be 60% scrap, 40% new steel, with additional alloying elements introduced to compensate for the contamination. The process was not elegant. It required constant adjustment, continuous testing, and a willingness to accept higher failure rates and quality control. But it worked. The steel that emerged from these hybrid melts was not as hard as German armor, not as pure, not as consistent, but it could be produced in quantities that dwarfed anything the Reich could achieve. By the summer of 1942. The Ford River Rouge plant alone was producing more steel per month than the entire Italian armaments industry. The Chrysler tank arsenal in Warren, Michigan, was turning out medium tanks at a rate of 1 every 4 hours. Each tank contained approximately 15 tons of steel, and roughly half of that steel had, in a previous life, been something else: a Chevrolet sedan, a plumbing fixture, a playground swing set. The American industrial base had become a vast recycling engine, taking the detritus of a consumer society and transforming it into the instruments of war. German intelligence officers, reading the production reports that filtered through neutral countries, assumed the numbers were propaganda. No industrial system could produce tanks at such rates, they reasoned, especially not tanks of combat-worthy quality. The Americans were known for their enthusiasm, their optimism, their naive belief that problems could be solved through sheer effort. But metal was metal. Physics was physics. There were limits to what could be achieved through volume alone. They were wrong, but their error was not technical. It was cultural. They misunderstood what American abundance meant. To understand the miracle of American scrap metal production, one must first understand the culture that made it possible. A culture that had been built over generations on a peculiar relationship with waste. America in 1942 was a nation of pack rats. The habit had been born in the pioneer era, when settlers lived hundreds of miles from the nearest source of manufactured goods and learned to save everything, to repair rather than replace, to stockpile against future need. It had been reinforced by the Depression, when millions of families learned that the broken washing machine in the garage might someday be the only source of spare parts, that the old car rusting in the yard was not garbage, but a reserve of metal and rubber and glass that might, in harder times, mean the difference between survival and destitution. This hoarding instinct, which seemed irrational to outside observers, created an invisible strategic reserve. Unlike Germany, where scrap metal was quickly reprocessed and returned to industrial circulation, American scrap accumulated. It piled up in farmyards and urban junkyards, in warehouse corners and municipal dumps. It was ugly, inefficient, and, by the standards of rational economic planning, wasteful. But when the war came, that waste became a resource. The scrap drives of 1942, the campaigns that sent Boy Scouts door to door collecting pots and pans, that stripped old battleships for their steel, that turned city parks into collection points, were not creating new material. They were activating reserves that had been quietly accumulating for decades. The symbolic center of this transformation was not a factory but a place. The vast scrapyards of Chicago, where dealers sorted incoming metal by type and quality. Here, the wreckage of peacetime America was cataloged, graded, and prepared for rebirth. A cast iron radiator became raw material for an engine block. A steel bed frame became armor plate. A child's tricycle became part of a tank tread. The transformation was literal, physical, and, to those who witnessed it, strangely moving. It suggested that nothing was truly wasted, that even failure and obsolescence could be redeemed, that second chances were not just a social philosophy, but a metallurgical reality. German soldiers encountering American tanks for the first time in North Africa in late 1942 noticed something odd. The armor plate on the M4 Sherman had a different texture than German steel, rougher, slightly pitted, with occasional inconsistencies in thickness. Some tanks showed weld seams that would never have passed German inspection. The tracks wore unevenly. The engines were loud and smelled of burnt oil. These were not precision instruments. They were, in the dismissive assessment of one panzer officer, crude machines, built by a crude people who understand quantity but not quality. And yet they kept coming. For every Sherman destroyed, 2 more appeared, then 3 more, then 5. The German tanks were better in almost every measurable way. Better armor, better guns, better optics. But there were never enough of them. A Tiger tank might destroy 4 or 5 Shermans before it was disabled, but the 6th Sherman would still be there, and the 7th and the 8th, and eventually, through sheer arithmetic persistence, the Tiger would burn. The symbolism of this disparity became, for German soldiers, a source of bitter reflection. They had been raised in a culture that valued craftsmanship, that taught them to take pride in doing things the right way, the thorough way, the permanent way. Now they were losing to an enemy who built tanks the way they built automobiles, quickly, cheaply, with an acceptance of imperfection that seemed almost contemptuous of engineering standards. It was not simply a military defeat, it was an aesthetic affront, a challenge to the entire philosophy of German industrial culture. The man who perhaps understood this symbolism most clearly was Dr. Ferdinand Porsche, the brilliant engineer who had designed the Tiger tank and who spent the final years of the war trying to solve the unsolvable problem of German steel shortages. Porsche was a perfectionist. His designs were elegant, efficient, and extraordinarily complex. The Tiger tank he envisioned was a machine that would dominate the battlefield through superior engineering. Thicker armor, a more powerful gun, an engine that could propel 60 tons of metal at speeds that defied conventional expectations. When he presented his prototype to Hitler in 1941, it was with the confidence of a man who had solved the problem of armored warfare through pure technical brilliance. But brilliance, Porsche discovered, could not be mass-produced. Each Tiger required components machined to tolerances that only a handful of German factories could achieve. The interleaved road wheels, which distributed the tank's weight so efficiently, required specialized tools to manufacture and hours to repair in the field. The transmission was a masterpiece of mechanical engineering and also a chronic source of failures. Most critically, each Tiger required materials that Germany could no longer reliably source: the tungsten for armor-piercing shells, the molybdenum for hardening steel, the high-grade nickel for electrical systems. Every one of these elements was in short supply, and the supply dwindled with each passing month. In 1943, Porsche was summoned to a meeting with Albert Speer and presented with a proposal that he found almost incomprehensible. Could the Tiger be redesigned to use lower-quality steel? Could the tolerances be loosened? Could components be simplified, made interchangeable, produced by less skilled workers in less sophisticated factories? Porsche's answer, delivered with the certainty of an engineer who had spent his life pursuing perfection, was no. The Tiger was an integrated system. Every component had been optimized to work with every other component. Reducing the quality of any single element would compromise the performance of the whole. You could not build a Tiger from inferior materials any more than you could build a Stradivarius violin from plywood. It was a question of fundamental principles. Speer listened to this explanation, thanked Porsche for his candor, and then quietly began shifting resources to the Panther tank, a design that was less sophisticated, less elegant, and far more amenable to production with substitute materials. Porsche would later write, in his private notes, that this moment marked the point at which he understood Germany had lost the war. Not because of any single battle or strategic failure, but because the enemy had made a different choice about what war required. The Americans had decided that a mediocre tank produced in thousands was more valuable than a perfect tank produced in dozens. They had sacrificed quality for quantity, craftsmanship for speed, and, most galling to Porsche, it was working. By the spring of 1944, the disparity had become undeniable. American factories were producing tanks at a rate of over 2,000 per month. The Sherman, which had begun as a stopgap design, had evolved through constant iteration into a family of vehicles adapted for dozens of battlefield roles. There were Shermans with flamethrowers, Shermans with bulldozer blades, Shermans modified to ford rivers, and Shermans modified to clear mines. Each adaptation required steel, and the steel came from scrap, from the endless reserves of a society that had never quite learned to let go of anything. Germany, by contrast, was producing fewer than 300 tanks per month, and the number was falling. The factories in the Ruhr were under constant bombardment. The rail lines that brought ore from Sweden were being severed by Allied air attacks. The stockpiles of alloying materials, carefully accumulated in the pre-war years, were nearly exhausted. Engineers were forced to make choices that would have been unthinkable in 1941. Armor plate was thinned. Components that had once been machined from solid steel were now fabricated from welded pieces. Quality control inspections, which had once rejected any part with even minor imperfections, were now passed as acceptable if the flaws were not immediately catastrophic. The psychological effect on German soldiers was profound. They had gone to war believing in the superiority of German engineering, in the idea that one German tank was worth 3 enemy tanks, that quality would always triumph over quantity. Now they were outnumbered not 3-1, but 10-1, and their perfect machines were being overwhelmed by enemies who seemed to care nothing for perfection, who treated tanks as disposable, who lost 3 vehicles to destroy 1, and considered it an acceptable exchange because 3 more were already on the way from the factories. A German tank commander named Hans von Luck, interviewed after the war, described the experience with a kind of mournful clarity. "We were craftsmen facing factory workers," he said. "We built each tank as if it were a work of art. They built theirs as if they were making sausages, and in the end, sausages won." The metaphor was more apt than von Luck perhaps realized. American industrial philosophy had always been rooted in abundance, in the idea that waste was acceptable if it enabled speed and volume. The German philosophy had been rooted in scarcity, in the need to make every resource count, to eliminate inefficiency, to achieve perfection because perfection was the only way to overcome numerical inferiority. But perfection required resources, and resources required supply lines, and supply lines required control of territory. And by 1944, Germany controlled less territory with each passing week. The physical symbol of this disparity became the object that haunted German soldiers' dreams, the sound of Sherman tank engines. It was a distinctive sound, loud, rough, almost cacophonous. The engines were not precision instruments. They were modified aircraft engines, mass-produced, designed for easy replacement rather than longevity. They leaked oil. They overheated. They required constant maintenance. But they were everywhere, and their ubiquity became a form of psychological warfare. A German infantryman in Normandy, writing home in July 1944, described lying in a foxhole and listening to the sound of American tanks moving up to the front. "You can hear them from kilometers away," he wrote. "The sound never stops. During the day, during the night, always the sound of engines, of treads on pavement, of metal moving forward. You destroy one, and the sound does not diminish. It is like fighting the ocean." This was the nightmare that German strategic planners had feared, but never quite believed would come to pass. The nightmare of fighting an enemy for whom loss was merely a temporary setback, for whom destruction was just an inconvenience, for whom every battlefield defeat was answered not with desperation, but with more tanks, more steel, more noise. The scrap metal that made this possible had become, in a sense, America's secret weapon. Not because it was technologically superior, it was not. Not because it was more efficient. By German standards, it was wasteful. But because it was abundant, because it could be replenished, because it represented a resource base that grew deeper the more it was used. Every destroyed Sherman was itself scrap metal that would eventually return to a foundry, be melted down, purified to acceptable standards, and reformed into new armor plate. The system was circular, self-sustaining, an industrial Ouroboros that consumed its own failures and transformed them into future success. Germany had no equivalent system because Germany had no equivalent culture. The German relationship with material goods was based on careful stewardship, on making things last, on rejecting the disposable and the temporary. These were virtues in peacetime. In war, they became vulnerabilities. A society that had never accumulated vast junkyards had no reserve to draw upon when the mines ran dry. A society that had built its industrial practice around purity and precision could not easily shift to accepting contamination and imperfection. The very qualities that had made German engineering admirable made it inflexible. And inflexibility in total war was a luxury no nation could afford. The epilogue to this story is written not in production statistics, but in the memories of the men who lived through it. In the spring of 1945, as American forces crossed the Rhine and drove into the industrial heart of Germany, they found factories that were still intact but silent. The furnaces were cold, the rolling mills were empty. In one Krupp facility, a warehouse held thousands of tons of precision machine tank components, gears, axles, armor plates, each one manufactured to perfect specifications, each one useless because the final assembly plants had been destroyed, and there was no steel left to complete the vehicles they were meant for. It was a monument to excellence rendered meaningless by exhaustion. American engineers touring these facilities after the surrender were struck by the sophistication of German manufacturing equipment. The machine tools were better than anything in American factories. The quality control systems were more rigorous. The technical documentation was impeccable, but none of it had mattered, because sophistication without resources is just another form of scarcity. One of these engineers, a man named John Morton, who had worked in the Detroit auto plants before the war, wrote a report that captured the fundamental difference between the two industrial philosophies. The German, he wrote, built perfect machines in inadequate numbers. We built adequate machines in perfect numbers. They assumed that quality would compensate for quantity. We assumed that quantity would compensate for quality. History suggests we were right, but I wonder if right is the proper word. Perhaps we were simply fortunate to have a society that hoarded its waste, fortunate to have junkyards full of obsolete machinery, fortunate to have never learned the virtue of making do with less. We won this war with our garbage, and I am not entirely sure whether that is something to be proud of or something to be troubled by. This ambivalence gets to the heart of what the scrap metal miracle represented. It was a triumph of pragmatism over idealism, of abundance over efficiency, of the chaotic vitality of a democratic consumer society over the ordered excellence of an authoritarian, militarized state. But it was also a reminder that war has its own logic, its own values, and those values are not always the ones we would choose to celebrate in peacetime. The 2,000 tanks that seemed impossible in January 1942 became, by the war's end, more than 50,000, each one a small piece of the vast, improvised, imperfect industrial mobilization that turned farmyard scrap into battlefield dominance. They were not beautiful machines. They were not perfect machines, but they were enough machines, and enough, it turned out, was what winning required. In the years after the war, American scrapyards gradually emptied as the accumulated metal of the Depression era flowed into the furnaces and became, in its final incarnation, the steel skeleton of the post-war boom. Highways and skyscrapers, bridges and automobiles. The Germans, rebuilding their shattered nation, adopted some of the American methods they had once dismissed. They learned to work with scrap, to accept imperfection, to value speed and volume alongside quality and precision. But the fundamental lesson, the thing that the scrap metal miracle taught about the nature of industrial power, remained uncomfortable. Even paradoxical strength, it seemed, could come from waste. Resilience could emerge from chaos. And sometimes in the ruthless arithmetic of modern war, the society that saved everything, that threw nothing away, that accumulated vast piles of obsolete junk in the naive belief that everything might someday be useful. That society possessed a strategic advantage that no amount of planning or precision could overcome. The junkyards of America, so often seen as symbols of decay and failure, had become forges of victory. The scrap metal, worthless, contaminated, impure, had been transformed into something more valuable than any virgin ore. A second chance mass-produced. The sound of Sherman engines faded from the battlefields of Europe in the summer of 1945, but their echo remained, a rough, imperfect, unstoppable rhythm, the sound of abundance meeting necessity, the sound of scrap metal becoming history.